Hello dear students, welcome to part 12 of the series of videos on amines. We've covered quite a lot in our videos where we've already spoken about the structure, the bonds, the bond length in alkyl amines and aryl amines. We've also done part of the nomenclature, preparation, properties, and we continue with the properties today, and we shall be talking about the reaction of amines with nitrous acid. Don't forget, yes, the pen and the paper. Now, the reaction with nitrous acid is an important conversion reaction as well as a test reaction. So, let's study this in greater detail. Nitrous acid. Now, nitrous acid is a very unstable acid, hence we prepare it in situ. That is, we take a nitrite salt and add HCl to it. There will be a double decomposition reaction and we will have sodium chloride and HNO2. So, NaCl and HNO2. Now, this nitrous acid which is generated reacts differently with primary aliphatic amines and primary aromatic amines. In fact, the reaction with primary aromatic amines is actually used as a test. We'll go back to that later. Primary aliphatic amines with nitrous acid. Primary aliphatic amines means I've got RNH2. Easy way to remember. So you have OH, N, O. This is my nitrous acid, CHNO2. What do I form? ROH, nitrogen, water. So it is a reaction which can be used to convert primary amines to alcohols. Also notice that the gas being liberated over here is nitrogen, and we get quantitative values. So 1 mole of amine is giving me 1 mole of nitrogen. Hence, this is a quantity, is a method which is used to estimate amino acids and proteins. Now, what is the reaction of aromatic amines? Now, this reaction we have already covered in 2 to 3 places. We have covered it under the topic of phenols, and we have also covered it under the topic of diazonium salts. Yes, I am glad that you are able to recall what we are talking about over here. Primary aromatic amines react with the nitrous acid, again generated in situ by taking sodium nitrite and HCl, and the reaction conditions are ice cold. Remember, we spoke about you carrying out this reaction in a dish containing ice cubes, and this is your test tube in which you are carrying out this reaction of yours. Do you recall doing something like that in the laboratory? Yes, so 0 to 5 degrees Celsius, and we get over here benzene diazonium chloride as the compound. Now, this benzene diazonium chloride is highly unstable, so we actually do not separate it from the solution and we directly carry out its reactions. There's a whole chart. This kind of a flow chart that I have shared on the channel, I will also share it at the end of this lesson. In case you have missed it out, you can use it to make the study of diazonium chlorides or diazonium compounds easy. So here we see that the diazonium compounds, they react differently with phenols and primary aromatic amines. In the case of phenols, the diazonium salts give you an orange dye, whereas in the case of primary aromatic amines, they give you a yellow dye. Now, you know why we said that this reaction is actually used as a test. Isn't it interesting? Yes. This chart and videos pertaining to it are already there on the channel. Please take advantage of it. These are all designed keeping you in mind. What about secondary amines and tertiary amines? Yes, in the case of secondary amines, with nitrous acid, we get a yellow oily product. You add an aqueous mineral acid, it is insoluble. Whereas in the case of tertiary amine, you either get a green product if it is an aromatic tertiary amine, or you get a soluble nitrite salt, which is indicative of an aliphatic tertiary amine. But this may not be required for most of the syllabi, so this part can be excluded. This was more from GK point of view, but in the meantime, would you like to copy down these notes so that you can have something for offline reference? Yes, and it will also help you enhance your learning. I'm waiting for you to write it down. You can always pause the video. By the way, for those who find this video very slow, there's always the option of speeding up the video 1.5 times, 2 times, 2.5 times, as much as you can grab. Go ahead. Have you written it? Don't forget, yes, I've left a blank over here. Why have I left a blank over here? Because I have shared this flowchart with you. Please go ahead and write it. Sharing this chart for the benefit of those who are interested in knowing what flowchart we were talking about. So on the left hand side you have reactions involving N2X negative, that is the diazo group, whereas on the right hand side you have the coupling reactions. This flowchart and many other flowcharts like this are already there on the channel. Please take advantage of those. In the next video, we shall be talking about electrophilic substitution reactions. Yes, these are usually easy and fun to write, but the problem comes in when their nitrogen is loaded with electrons. And how does it affect the behavior of the compound? So especially the benzene ring. We shall see that in the next video. So stay connected, stay happy.